And so my main goals for today are to introduce the overall data science initiative at the U of O and provide details on the undergraduate program in data science that we've developed and that we'll be launching in the fall of 2020, so just in a few months, and set the stage for subsequent discussions of graduate programs and development of those programs in subsequent webinars. So before I get going, I wanted to just thank all of you for being here today and for providing learning more about the data science initiative at the U of O, and also for any and all questions, input, and advice that you can have. So we're going to actually structure this around two sessions. First, a few minutes, I'll give you an introduction to the overall data science initiative at the U of O, and then we'll allow a little bit of time to actually then answer questions, take thoughts from you, and then after that, we'll dive into the undergraduate program in data science. And I have a very specific question that I wanted to pose to the group and get some feedback on that. And then finish up by setting the stage for subsequent discussions, as I said, of graduate programs. So really one of the first things we have to ask ourselves is, what is data science? Because this is one of those terms that's a term of art now, but it means different things to different people. So the University of Oregon is a research a university, so a high level of research activity in a variety of different areas, but it also has a strong history of liberal arts education. And so data science to us at the University of Oregon has been happening in numerous different places and departments across campus, from our computer and information science department, departments of mathematics, but more importantly, it's actually in areas where data and large amounts of data are being generated, gathered, and analyzed. So for example, departments of geography, biology, our College of Education, areas in business and business analytics. So for us, we've defined data science as an interdisciplinary field focused on extracting knowledge from data. So it's not just about the analysis, but it's actually about how do you extract knowledge from data. So there's some key components of this. One is that it's not just small amounts of data, but big data. So big is a relative. What does it actually mean? Well, in general, big data has four components to it. And oftentimes, many of you are familiar with this, the four V's. So there's a lot of it. So it's the volume. It's generated really rapidly and continuously. So velocity, we have to consider that it's not one and done, but it's continuously occurring. It takes many different forms and type. The days of saying you have one data type and analyze that and get a result are long gone. So we have to take into account how those different forms and types of data are brought in, analyzed, and integrated, and the fact that the veracity of those data is unclear. How much should we trust those data, where they're coming from? What are their source? What are the provenance? All of those things are components of big data. But data science by itself is much more than the data. It's actually the tools, techniques, approaches, and structures by which one can analyze those data to extract useful knowledge. So oftentimes I'll get the question, and others will get the question, well, how is this different from computer science and statistics? Well, statistics and computer science is really important for all aspects of data science. But by themselves, they're the tools that allow that extraction of useful knowledge from the data. So what is useful? Well, this is a key component of data sciences. It depends upon the domain or the field in which the work is being done. So data science almost always has a strong domain component to it, because the science of using the data, the big data, and the analytics is for a purpose in a field. And that's really a key component of what's informed what we're doing at the University of Oregon, both in terms of our enhancing research and developing new educational programs. It's not just the big data, the data analytics, but it's the domains and how do we actually build all those together. And I think for many of you, you deal with this all the time, is that similar tools and approaches that might be completely appropriate in one area or one business or one sector of the economy could be repurposed, but would take on a different form or flavor to them. So an aspect of the data science is the interpretation, or what's sometimes called decision science. So, how does one make decisions based upon those data? And once those decisions are made, how can you communicate those findings? I oftentimes use this example. I develop Bayesian computational genomic technology and analytical tools for genomics. But when I actually go to a doctor's office and try to figure out what the outcome of a genetic test is, it's difficult for me to actually myself even have that conversation with the medical staff. So how do we actually incorporate in our training the ability to communicate findings and not just make decisions? But of course, putting these all into the context of the ethical, legal, and societal context as well too, because it's not just what can we do, but what should we do with the data and how we make decisions from those. So if we think about what this means from the standpoint of not data science, but a data scientist, and this is what's actually really informed the way that we've been thinking about data science at the U of O, is what would she or he, after graduating from the University of Oregon with an undergraduate or graduate degree, have in terms of their knowledge, skill sets? Well, it's really, there's some fundamental knowledge in terms of statistical modeling, machine learning approaches in optimization, all of the key components that would go into many degrees in computer science, statistics, or applied math. But there's really the domain knowledge as well too. And so that domain knowledge has to be married with that aspects of programming and databasing, and like I said, the communication and visualization to be able to communicate that information out to the world. So this has informed the way that we've actually thought about data science at the University of Oregon. So many different units at the U of O had been working on and integrating data science into their education and research programs. And in 2017, our then provost, Jayanth Banavar, came to the University of Oregon from the University of Maryland and asked me to actually lead a committee of faculty and other thought leaders at campus to develop a program that was uniquely U of O, that would serve the University of Oregon, but also and build upon the long history of interdisciplinary research and liberal arts that defines the U of O, that would integrate applications of data science across all schools and colleges. So this is a university-wide initiative. Advance new research and educational opportunities, not simply rearrange what's already happening, and to some extent mitigate what we've called historical weaknesses in methodologies of data science. The University of Oregon has never had a Department of Statistics, for example. So how do we actually think about developing new approaches and foci? So based upon the advice of this committee, we developed a university-wide program in data science that had these principles: that the data science initiative should cover all aspects of the university because data science is transforming nearly every aspect of society. And therefore, the initiative, whatever gets developed at the U of O, should be large enough to grow interdisciplinary research efforts. So a number of our goals in the research areas are to develop the infrastructure, whether that be computational infrastructure or training in different ability for graduate students, faculty, other researchers to utilize tools and techniques to facilitate collaborations across universities, but also public-private partnerships are extremely important, and maybe I'd be happy to talk with any of you about some of these in the future. And really, a lot of it was focusing on development of collaborative efforts with academic institutions and industry. Ultimately, our goal is to actually have, because we are a mission-driven institution to serve the state of Oregon, the region, and the country, is to ultimately have positive impacts on society. So data science utilized for the public good. So there's numerous different things that are happening in terms of multiple interdisciplinary research efforts. For example, we've launched a biomedical data science center that's a collaboration between the Knight Campus for Accelerating Scientific Impact at the University of Oregon and the Knight Cancer Institute at Oregon Health and Science University to bring together data science, biomedical data scientists, new researchers, and new educational programs that help apply data science techniques to the collection of genomic and other types of biological data to be able to detect diseases and prevent diseases earlier, faster, and better. And that's one aspect of that. And so there are numerous different research efforts that are being supported across campus, from the use of wearable technologies to geographic information systems, where we're gathering information in a spatially and temporally informed way. But I really wanted to focus today on some of our efforts that are going on at the educational level, because that's a place where I think all of you probably might be. Uh, it, it would be really helpful to us from the standpoint of the undergraduate program and where we're going and what we've built, and our graduate programs, to hear what you need. What is it from the students that come from the U of O through our programs that can best serve the needs of your your company, your unit, whatever your long-term goals are. So I just wanted to finish up this section by talking about some of the implementation activities that are happening at the University of Oregon. So in terms of the overall data science initiative, and then dig into the educational components of things. So first off, one of the major activities that we're doing at the U of O is building the infrastructure and community. So we've made a number, meaning the U of O has made a number of investments in computational technologies. So the U of O has just finished undergoing, and it's finishing out a huge process called Transform IT under the leadership of our Chief Information Officer, Jesse Minton, who many of you actually know. And that's been a really important activity that's actually occurred that allows us to optimize and hone the use of technology for all academic activities, educational, research, and the overall running of the university. In addition, we've created really cutting-edge computational resources under the leadership of the Vice President, Office of the Vice President for Research and Innovation. We've created the Research Advanced Computing Services group, which is a core facility that runs the Talipus supercomputer, and that group is led by Nick Maggio, who's actually a PhD applied scientist, and many of you know Nick as well too. And those physical and resources that are available at the U of O are really supporting the U of O research. But like many of our core facilities, we're thinking about opportunities and possibilities for supporting private partnerships as well too. We have many other informal activities, including machine learning meetups and seminars and things like that. So a lot of our effort, though, is designing UO optimal educational activities, meaning what is it that really fits the unique nature of the U of O in the context of our community in the state of Oregon. That's why we're so pleased to actually be here today talking to TAO about these things. And a lot of our focus over the last year and a half has been developing and getting approval and now launching an undergraduate data science major that I'll tell you a little bit more about in a few minutes. And then support the growth of domain applications of data science in other departments around campus. So to making sure that a student who comes through with a degree in linguistics who wants to have training in data science and linguistics is supported by the data science initiative. So we're actually helping develop new courses at the higher levels to help students have training in data science regardless of what their degree is. And we're really thinking about a university-wide interdisciplinary program in data science, and we actually have launched that program. And so I'll tell you a little bit more about it in the second half of the webinar today. But a key aspect of this is we're at the U of O actively contemplating whether data science literacy would be a core component of all education of all students who come through the U of O. And we feel like this is a very important thing. And then really develop immersive experiential internship-based programs developed on external input. So at the end, we'll talk about the subsequent the webinar next week that will be led by Dr. Stacy Wagner. So Stacy is our director of the Bioinformatics and Genomics Master's Program at the University of Oregon and the Night Campus Internship Program. And really, she'll tell you a lot about these immersive internship-based programs that she and others have developed, and thoughts and she'll solicit your feedback on developing a new internship-based program in data science that I think would be really exciting for many of you. And as I mentioned, we're really trying to support research foci, including the infrastructure, postgraduate short courses, consulting and support, and seed funding for novel data science research at the U of O. But we have a specific eye to thinking about the development of these that might not just serve the U of O, but serve the building of connections inside and outside of the academy. So, for example, developing short courses that could be available to those outside of campus as well as on campus, but also helping facilitate through seed funding novel data science research that's public-private partnerships, which would be very exciting. So I wanted to end at that point. There's many other things that could actually be discussed on these different areas, but I just wanted to open it up for a few minutes on thoughts, input, questions about the overall program. I thought for a little bit about prompting questions for you that I had for the overall structure, but I have one for the second half on the undergraduate education. But I just thought this would be an opportunity to open for, let's say, the next 7, 8, 9, 10 minutes, just to any thoughts or feedback.
Folks are welcome to share questions in the chat, or if you want to open your mic really quickly for a question, you can do that as well.
Good morning, Jeff Petrie here from the city of Eugene.
Hi, how are you?
Good, thank you. We have just started our Smart City Data Science program through our parking program.
Right.
And we're also involved with economic recovery, community recovery. And I'm wondering if you have any thoughts you could talk to about how we could leverage U of O resources and to think about community recovery from the COVID event.
Yeah, I think that's a really good question. This moment, I think in terms of the smart cities, so I'm sure you're working with the Smart Cities Initiative here in the College of Design at the U of O. Am I right about that?
Yes, we've had some interplay, but we're really I can shoot my video. We've really kicked off more of an internal structure that we're getting our house in order first before we reach out externally.
Yeah, I think that's one key area that could be beneficial, is to actually work with Nico Larco, who's the director of that program, and then and also think about ways to interface with that group. I think from a larger standpoint of how to imagine the community recovery, there's a variety of different opportunities. I mean, one of the most immediate things is from the standpoint of being able to help, honestly, with testing for the COVID-2, so the coronavirus, and the presence and prevalence. And we have a number of our data scientists in the initiative actually helping with efforts in collaboration with to develop novel testing and then develop pipelines for not only testing in the community, but also then for contact tracing and in working in partnership with Lane County Public Health, and then also the OHA, the Oregon Health Authority. So obviously we're right in the middle of this pandemic right now. So being able to gather, and that's a perfect example of being able to gather data on prevalence rates, model the development of the disease, and to ask about key parameters like if we were to increase movement and contact. Some of our data scientists have developed a spatially explicit model of infection that says, what if people moved around campus and around Eugene in this way? What would actually be the consequence of that? So I do think part of the recovery here, and where data science can help, is from the standpoint of informing the use of information for decisions and key leaders with that. But in the long term, so that's in the immediate term, if we think about before we end up with a vaccine, for the long term, our society will never be the same. I'm convinced now, I was convinced before, but even more so now, that the the use of information technology in and data science is really going to transform nearly all sectors of society. I can even see just my future as a faculty member. I'll just be doing a lot more of my work in the ways that I have been over the last 2 months, I think. And so, in terms of the the, the specific aspects of things for recovery in the community, it's both the training of the students, but thinking about ways where there could actually be partnerships with the city of Eugene and the U of O that then helps. I can imagine the development when we talk about the undergraduate program here in a second. There's a key aspect of capstone projects. Could we actually help develop capstone projects that some students would work on? Key questions or problems that the city of Eugene needs to have some thoughts and work in data science on. But those are just thoughts off the top of my head right now.
It looks like there is a question, Bill. It says,
Mhm.
what is U of O currently doing to engage the industry in data science? And then another question is, in my experience, data literacy is key competence for all technology and technical management staff. Does your plan include this?
Yeah, so data literacy is a key competence for all technology and technical management staff. Yes, it does. Yeah, and you'll see that in a second in terms of the undergraduate major, and that's a key bit of information in terms of the feedback for the development of the graduate program as well too. Yeah, so it's not just the the tools, but what are the nature of the data and what are those actual types. So from the perspective, I'll just give a perfect example of this that Stacy can talk a little bit more later on. Uh, when when the bioinformatics genomics master's program was developed, and Stacy was instrumental in this from the beginning, we had a really strong view that the students shouldn't just be trained in the computational approaches with all of the genomic data turned into zeros and one. They should actually be at the bench and learning what the data generation process is, warts and all. But then aspects of databasing and what types of different databases are, and then pluses and minuses. So that is a key component of that. So in terms of the question from Stacy to everyone, what is U of O currently doing to engage with industry in data science? And so part of the efforts here around these webinars is exactly, this is one of our first big pushes, is to, we've had individual conversations with thought leaders in the community around the country, especially in the West Coast. You can imagine Seattle and the Bay Area, but really a lot of the work over the next couple of years kind of kicked off through these webinars is engaging and trying to deepen engagements with the local community. So we'd appreciate any feedback from you on ways to do that efficiently, effectively, and more and better. Any other thoughts on the overall structure for the data science initiative? And so there is a question. So what does an initiative mean? We initiated something. Ultimately, the initiative itself was meant to go away. It was meant to be sunsetted. Something you oftentimes don't hear from things at universities or other places. But from the very beginning, our goal was to be a university-wide structure as initiative that helped start things up, new educational programs, new grad at the undergrad, graduate, new research programs, new centers. But eventually, the initiative becomes institutionalized in those other things that are formed. So now is a perfect time for the community in Oregon to help us institutionalize things that are mutually synergistic and beneficial. So if there's no more questions about the overall initiative, or if you do and there's additional, I'm happy to talk more with any of you individually or outside this, or I would point you to our web resources as well. Our entire vision document that was created for the development of the initiative at the U of O is actually posted on datascience.uoregon.edu. And that's something that we can follow up later on with the um, uh, and get that information to you if you'd like. What I thought I would do for the next part of this is really just talk about the development of our undergraduate program at the U of O. So we saw this as one of our first major places where we wanted to put effort is, could we develop an undergraduate program that has a flavor to the U of O? So I wanted to describe a little bit to you how we went around doing the market analysis. And by that, I mean asking what other programs have been developed at different universities around the world. We're not the first, nor will we be the last. And our program should not just look like any other program. And then I wanted to tell you what that led to in terms of our really embrace by the entire university community of the development of this university-wide undergraduate program in data science and what that looks like. And I'll tell you a little bit about the training. And at the end, solicit feedback from you about ways as we launch this to really optimize it for the future. So let me tell you about this major. So as I've mentioned several times, this is a university-wide major. So what does that mean? Well, most majors that exist at this university and other universities have a home. You might have a major in marketing that exists in our College of Business, or a major in anthropology that exists in our College of Arts and Sciences. But because of the way that data science is so critical and important for nearly all aspects of the academy, nearly every school and college we looked at, we couldn't see a school that wouldn't actually benefit from and be transformed by data science. The only one that initially I thought, well, maybe not School of Music and Dance, and that mistaken impression was quickly disabused when I realized all of the aspects of the use of data science in terms of things like sonification that I had never even thought about, and how important that was for the School of Music and Dance, all aspects of the university. So we developed a program that lives right now in the provost office. And this program then has the degree that's a strong quantitative, strong quantitative emphasis and component with an emphasis in domain areas. So we call this a data science plus domain degree. And the reason that we actually use that terminology is because it's a little different than what other universities have done, which is oftentimes described as domain plus data science. And by domain, I mean the area of traditional knowledge or data literacy components of that group. So for example, some universities have developed the adding data science to every existing degree across campus. So those domains of those degrees, as much as possible, have data science added to them. But we actually felt like, because we had the opportunity at the U of O, in some ways it's like the launch of the Night Campus for Accelerating Scientific Impact. We didn't have historical structures that were colleges of agriculture or engineering or medicine, where maybe the fields of statistics or applied mathematics would have been developed and in some ways formed silos. We had the opportunity to start from ground zero and develop data science plus the domain in the way that matched the U of O. So I'll tell you more about that in a little bit, but I just wanted to give you a sense of, from our analysis, what we anticipate. And we're seeing this now in our response this spring for enrollment. We've had numerous students actually contact us and say, now that I know that you have a data science degree, I've actually chosen to come to the U of O for that degree. We'll launch the degree this fall, 2020. And over the next 5 years, we anticipate that it'll grow to 400 students, incoming students per year. And we started with 5 exemplar domain areas, and I'll tell you about those a little bit more in a second. And this is not meant to be the complete, but we meant to cover kind of key aspects of the university. So from the social sciences and humanities to the natural sciences to schools that might be more professional schools like the College of Business. So linguistics, geography, biology are all in the College of Arts and Sciences, whereas market and analytics and accounting analytics are in our LCB, our College of Business. And very quickly this coming year, we're adding as additional emphasis areas onto this. So we anticipate having dozens of emphasis areas. And so here's at the bottom just an estimate of the growth of the number of students that are actually coming in. So at the end of this, our students will be well trained, we feel, for applications of data science in a number of different domain areas. And this really, our hope is that this serves the state of Oregon and the country through providing this critical workforce for the future. So how did we come about doing this? Well, I really have to give a huge shout out to Joe Sventek. So Joe is presently our head of computer information sciences. We actually recruited him here from the University of Glasgow after he actually finished his PhD in nuclear physics and spent time in the private industry in HP. And he really took the lead on this and is starting this summer going to be our inaugural director of the undergraduate program in data science. So what Joe and several others, in particular, I'll mention Nathan Jacobs, spent a fair amount of time doing surveys of existing American Association of University institutions. There's 65 of those. These are considered the major research universities across the country, plus Oregon State and Portland State. Out of those, 42 had an undergraduate degree in data science and/or a graduate degree in the data science realm. And one of the things that we noticed right away is that there were very few programs that had PhDs in data science. And in some ways that makes a lot of sense because a data science degree might be similar to a degree in engineering in some ways. And that many of the degrees that were PhD that might have data science components were focused more in a domain area. So we really focused first and foremost on the development of an undergraduate program. And then as you'll see for the subsequent webinars, a lot of the effort now at the U of O in the Knight campus and the Data Science Initiative is thinking about development of these really targeted master's programs in the data science realm. So the visioning committee recommended a strong application aspect to the degree, but only 4 comparators that we looked at, Iowa State, UC Berkeley, UC San Diego, and the University of Rochester, had those strong domain components to them. So that question that came before in terms of the data science literacy. And it was really interesting to see because when you looked at these 4 institutions out of that component, they were similar in some ways, but they actually had some interesting differences. So for example, Iowa State had a strong domain emphasis, but they're really focused in the sciences. And that just didn't match the U of O in terms of who we are. We have a strength and excellence in all areas of our university outside the natural sciences. UCSD, very similar, very science domain oriented. And Rochester, it was very science and engineering oriented. The only university that really kind of lined up well with the vision that we had in some ways makes sense because there's this longstanding connection between Berkeley and the U of O in numerous different ways, similar status in the state and then positioning, is that the one at Berkeley was a very well thought out structure that included science, social science, and humanities in 25 different domains. So it really matched what we were actually looking for. And it was developed at Berkeley in a way to be an open source. It was really done with this open source mindset. So just to dive into the weeds a little bit, nearly everything they put together were GitHub repos, repositories, and really deep documentation in ways that could be adapted for other programs. And so we really looked closely at the Berkeley model and adopted a lot of the different components of it and then tailored it for the U of O. So the science degree at the U of O follows a very similar approach, which is this. If you look at this on this figure, this diagram, starting at what we're calling the foundational or lower level division courses, we developed 2 new courses that will be taught starting in the winter of this upcoming academic year. So starting January 6th, I think is the first date of 2021. It's called Data Science 101 and 102. They're very similar to a course at Berkeley called Data Science 8 that presently has that's a general education course, as will our courses be, that at Berkeley, I think has 1,500 students in it per year. So this Foundations in Data Science covers the broad introduction to all the different aspects of data science, not just data analytics and statistics, but what are different types of domains where data science is applied? What is decision research? A key component of everything we're doing, though, has an ethics training as well too. Every course that's here says, okay, what are the ethical and societal implications of the data analysis that you're doing? And one thing I forgot to mention, and I apologize for this, is in the overall data science initiative, that data science initiative has been helping guide our hires that of key faculty over the last 3 years. So we've made a number of hires of faculty into departments that have strong data science experience, research programs, education, and credentials, and they cover the university in our College of Business, our College of Education, in our in College of Arts and Sciences, including in departments that at first blush you might not think, well, that's related. We have strong hires in data science ethics in our Department of Philosophy, who are actually have developed and will be teaching courses in data science ethics as part of this series. So back to the foundational lower division courses, if we look at this area over here, the breadth and electives, the idea is that for each one of the domain emphasis areas that exist in the data science degree that partner with the data science program, for example, Department of Geography, they're the ones that say, for anyone who's a geographer, or to take the example as a biologist, these are the fundamental things you need to know as a biologist. Here's these fundamental intro courses for you to know anything about the data that will be analyzed, that you'll actually be using the tools later on. So these are the foundational courses. They themselves may not be quantitative, but they're absolutely critical for that chosen domain that student. So a student comes in and very quickly says, yep, I'm a data scientist and I'm in the major, but I want to have a domain emphasis in biomedical data science. I'm actually going to do a domain emphasis in biology. So here's the course that I actually take at the same time I'm getting the foundational courses in data science. And then we have a set of mathematics courses and computer science courses, the standard ones you can imagine, numerical linear algebra, databases, things like that as well too. But all the way through, that domain emphasis continues. So there's a certain number of electives and requirements that actually happen. And then at the 300 level, we have another core class that's the data science 311 that in many ways is the advanced course of data science 101 and 102. So these 101 and 102 courses are all developed to have a common framework. We're actually using Jupyter notebooks to go through and teach all the students actually how to do the foundational things and have this coordinated framework. But then once they get to the 300 level, then they're really starting to branch out, because not everyone's going to actually be doing the same things in Python. So they'll actually, even though that'll be a core aspect of the teaching early on, they need to be exposed to different languages, different approaches, really all of the warts that and the vagaries of the world. And then these upper division courses really involve much more in-depth Bayesian hierarchical modeling in terms of statistics and probability, a brand new machine learning course that we've actually developed for the series. And then in partnership with those domains on campus, there have been new courses developed that are quantitative in nature. For example, in biology, there's an upper division course that's mathematical modeling in biology. And so it's meant to be strongly integrated with the aspects of things that the students learn at the in their data science and applied in the domain emphasis area. So along with that ethics component, and then an optional capstone. And here's a point where I think would be really useful to think about partnerships. And back to that question that Jeff asked early on, these capstone projects, we really are thinking of these as many students as possible, connected with real world applications of the tools, techniques, and approaches that are being utilized there. And so I think there's an opportunity there for a lot of those partnerships to be happening with for local, regional, and state government, as well as industry. So that's the overall structure of the program. And so we really need to ask the question, what are students going to do with this degree? Well, we feel like that structure of the core plus the domain emphasis helps students develop the skills, apply them immediately, but then allow them to go through the 10 to 15 different career changes throughout their lives. I mean, really, that's something that all of us, or maybe not 10 to 15, but the point is that those skills and the ability to pivot are going to be critical for them, and not just so the domain that they apply it to initially is an important aspect of it, and that might be the domain that they stay in for the rest of their lives, but just as possibly they could end up transitioning to another area. So where do we think they'll find jobs? There's a lot of jobs out there in data science: banking, healthcare, biotech, government, nonprofit, automotive, and aerospace. I mean, if you think about nearly every industry, there's a data science component to it. And so we really think that that this degree is going to be pretty useful and helpful. But we're trying as best we can not to do the academic thing, which is to just navel gaze and say, well, we think we're doing a good job because we say we're doing a good job. We want to continually have this informed by the input of others. And so I'm just, in the interest of time, I just wanted to finish up here and really ask this question, and we probably won't have enough time to answer it today, but that we constantly want to be, as we continue to expand the different domain areas and refine the undergraduate education program, get feedback from all of you and others. What skills, proficiency, or knowledge in data science are critical for students to be successful in your industry or more generally prepared for the rest of their careers? And we want this to be a constant dialectic and dialogue between the academy and off the academy. So I'm going to finish up at that right there. And if there are any key questions that people have about this, I'll stay on a little bit, but I just wanted to point out the goal for next week's webinar. As I mentioned, Stacy Wagner will actually be leading that webinar, and I'll be there as well too, and several others from the Bioinformatics Genomics Master's Program, the Night Campus Internship Program, but others. But really, we want to say you're going to learn about this successful program in genomics and bioinformatics that Stacy leads. And you'll hear about the employment metrics and what they do and how this application of data science to this area has really allowed this to succeed in partnership with external stakeholders who hire the interns and graduates. And these hands-on industry-informed training gets modified every year, meaning they ask the industry, what's next? And there's been all kinds of modification of the training that's happened through that input and because the field changed. So a lot of input next week would be really think about development of complementary training, data science challenges, talents gaps, and figure out ways to grow your network and partner with the U of O. And so next week's conversation, we really, this week, the webinar was a lot of the introducing of the key foundations of what we're doing, because this is really, we're kind of rolling out the information now, and we want, and Stacy really wants next week's conversation to be really feeding in terms of the informing who we are, and do that in a way that best fulfills the needs of society, really. So with that, I think what I'll do is I'm happy to stay around for a while longer and ask questions, answer questions, receive feedback, and anything afterwards would be great. But I just wanted to again thank all of you for being here and for hearing about what we're doing, and any input, feedback, and connections that we make in the future. So thanks.
You're welcome to also send either Ruthie or I an email at techoregon.org. If you'd like to ask additional questions, we can pass those along to U of O. And then if you have interest in joining us next week, feel free to send me a direct message in the chat, and we can make sure that you're re-registered for that event. And apologies for the link being incorrect on some of those registrations. Hopefully we got the majority for the event.
Well, thanks. And I'll just point out, Jeff, that asked that or made this good point. Challenges helping organizations and people thinking about creating positions. What a data scientist is. That's exactly right, and I think that's a good point to make. Which is, and why we try to actually have that slide about what is a data scientist. What do they do? So to let people know that they're probably many of the things they're thinking about what they need are data scientists. Thank you, Annie.
One question I do have, Bill, is how do we couch this for high school students who are looking to get into tech but don't really know much about data science? That's something that we talk to a lot of different organizations and schools here locally. So how can we let them know on our end?
Yeah, that's a good question. Yeah, and we're actually struggling with that ourselves in terms of, well, to be honest, our communication plan around the major so far, it's been by word of mouth. And in some ways, we decided we have information that goes out to our students who are contemplating whether they could come to, they're interested in coming to the U of O. But that's not, you're asking more broadly and appropriately, is more across not just that small subset of students who have already thought about and applied to the U of O, but more broadly about that. It does feel like there's that having an outreach component to um, schools would actually be really a good way to do it. Maybe involve some of what we have at the U of O and other programs is involvement of students from K through 12 as well too in aspects of things. I wonder if that could be a component. But I think we would, if you or others have thoughts about good venue to do that, or if there's ways that we can partner to do that, I'd be all ears for that as well too. Because TAO does events at schools, right?
We provide resources for schools and organizations that work with youth and actually older youth who might not have graduated from high school about getting into different career sectors. So this is definitely something I'd love to have a conversation with you, maybe even a web series for students to let them know about a data science track for them, because it's not something they often hear about when STEAM and STEM.
Yeah, exactly. And um, I think providing the material, getting the materials together in partnership to figure out what would be the most impactful for those students would be really helpful. And if there are places where we can invest in not only creating those materials, but the framework for doing that, I think that would be a great place for resources from the initiative to be invested. Because it is true, there are a lot of students who say, I don't want to be a computer scientist, but I want to do X, Y, and Z. And they're effectively saying they want to be a data scientist, but they just may not know that's what they actually want to be, because that the terminology um, is foreign to them.
Well, thank you so much. We really appreciate learning more about the programming and the things that you're working on at U of O. And we're happy to answer any more questions. We'll give it probably 4 more minutes, and then we'll be logging off this webinar. Thank you again, and we hope to have everyone join us next week.
Thanks, Bill. Have a great day.
Great, thanks.
too much silence there. So
Okay.